Okay, students, we're going to look at lesson 6.5, example 3. So hopefully you looked at my basic information, and so we're trying to figure out where this quadratic is true. So where the quadratic is greater than 0. So the first thing we're going to have to do is try to factor. Now we're looking for factors of 6 that'll add and give me 7. That would be 6 and 1. But this is a little different. One's going to have to be 2x, and the other one's going to have to be x. Now, since the last sign is plus, both of them are the same sign, and they're both that sign. Now I just have to decide where to put the 3 and the 2. Well, if I put the 3 here, the answer is going to be 5. But if I put the 3 here, I get -6, and the 1 here I get 1 for -7. Okay, so now I'm going to work this problem using my method, okay? And it's the method that most students understand. So what we're going to do is we're going to solve that for 0. Let's see, 2x minus 1 equals 0, 2x equals 1, so x is 1/2. Okay, well, you may have known that anyway, so 1/2. All right, and so what value of x causes the second factor to be 0? It's 3. Now, we're going to call these our critical points. These 2 points are our critical points, and we're going to put them on a number line. Now, watch how I do this. 1/2 comes first. We're going to put that here, and I'm going to put the 3 here. Now, in essence, what we're doing is we are dividing the number line up into 3 regions. Region 1, Region 2, and Region Spank. No, just kidding. And Region 3. Now, if it's true for any value in this middle region, it's true for the whole region. That is key. And that was previously explained. So the only thing I need to do is pick some test numbers. Now, I could pick 1,121 here, but I'm not. I'm going to pick an easy number, like 4. So 4 is my test value. Here, I'm going to pick an easy value, which is 1. Here, I'm going to pick the easiest value in the whole world, which is 0. Okay? So 0, 1, and 4 are my test values. Now, how do I use these test values? Well, what I do is I put that value, I could put it in my original equation, but I'm going to put it over here. When I put 0 in for here, I get 0 minus 1, which is -1, times, I put 0 in for here, I get -3. Now, what is -1 times -3? That's 3. Okay, that's 3. All I really care is if it's positive. Is that positive? Yes, it is positive. Okay? It is positive. Now, is that what I'm looking for? 3 is positive. Yes, it is what I'm looking for, so it's true. I'm going to put a little T for true. Okay, I'm going to pause this for a second. Okay, now I'm going to go to this 1 right here, and I'm going to plug in 1 for the x. 2 minus 1 is 1. Well, that's a plus, right? And then let's plug the 1 in over here. 1 minus 3 is -2. That's a negative, right? So what's a positive times a negative? A positive times a negative is a negative. Now, I'm looking for where x is greater than 0. Negative is less than 0, or it's under the water, if you would. So that is false. Okay? Now, you may want to think these toggle back and forth all of the time, but they don't. So plug in the 4. That's 8 minus 1, which is 7. That's just a plus. And that's 4 minus 3, which is 1, which is a plus. What's a plus times a plus? It is positive. That's what we want, so it is true. Okay? Now what we got to do is we have to identify the true regions. When I say the true regions, I'm talking about, remember, it can't be the critical point, but it's true for every value in this region. It's not true in this region. Here's my critical value, but it's true for every value in that region. So how do I describe this in interval notation? Well, it stops at the 1/2 and it goes forever and ever to the left. That would be negative infinity, parenthesis, always next to infinity. And then over here, 3. It can't be 3, so I'm putting a parenthesis there, common infinity. Okay? And this means, or. It means both of them. So this right here is my answer to that question. Hope that helps.